Welcome to Engaging Saturdays with EM Educational Services. My name is Jennifer Bell and I am your host for today. Today we're going to be exploring the concepts of chemistry and electricity. Together, this creates the science of electrochemistry. Chemical reactions occur every day all around us. The air that you breathe when you breathe in and breathe out, that is called respiration, and respiration is a chemical change. We breathe in oxygen, but we release carbon dioxide. That's because our cells convert the oxygen into carbon dioxide once they've used the oxygen to perform their functions. A banana that you leave out on the counter, have you noticed that it turns brown? Well, that's an example of a chemical reaction. Eating, the digestive system, is another example of a chemical reaction. Your body absorbs the nutrients and the vitamins from the food after it's broken it down using the acids in your stomach, and it changes the food into these nutrients so that your body can use it to perform its functions and so that you can live. Chemical reaction. Well, what does this have to do with electricity, you may ask? Well, everything in the universe is made of atoms, and atoms are constantly creating and breaking bonds with other atoms. They do this when the electrons move from one atom to another. This energy that's released when electrons are moved can generate electricity, and we can harness that energy. But we can also use electricity to let us know if a chemical reaction is taking place, and we can use electricity to induce a chemical reaction. But why talk about all of these concepts when we can just bring them to life? Grab your KiwiCo kit and let's get started. So for this first experiment, we are going to generate our own chemical reaction. You will need the following supplies. You need to fill your beaker up with warm water to about the 25 milliliter line. You will need your blue scooper and your stirrer. You need the aluminum foil and plastic cup. You also need your copper sulfate and your sodium chloride. And last but not least, don't forget your mess mat, because this is science and things can get messy, but that makes it all the more fun. The first step is to take the sodium chloride, and I want you to pour a half a scoop of sodium chloride into the warm water. Next, you're going to take a scoop of your copper sulfate and pour it into the warm water as well. Mix the solution with your stirrer, making sure that the copper sulfate and the sodium chloride are dissolving into the water. Now that we have stirred that, you're going to take your solution and you're going to pour it into the plastic cup. Next, take your aluminum foil and gently wrap it around the edges of your empty beaker. And you want to create a bowl shape, just like this. So after you have secured your aluminum foil onto your beaker, now it's time to get ready to see the chemical reaction. Now, depending on how much sodium chloride or copper sulfate you added to the water, that will change what you see with the reaction. So it may happen very quickly for you. For others of you, it may take a little longer for the reaction to occur, but you will notice something. While the reaction is occurring, I want you to pay very close attention to what you observe. Before you pour the solution onto the aluminum foil, I want you to stop and make a hypothesis about what you think will happen. Next, slowly pour the solution onto the aluminum foil and pay close attention. Let's take a moment to reflect on our observations during our chemical reaction. So if you look at your aluminum foil, you should notice a reddish brownish substance that is now kind of growing on top of your aluminum foil. I also noticed that there are some holes now that have formed in our aluminum foil, and it seems to be a little bit more fragile as well as kind of tearing easily. You should also notice, if you look at your beaker, you may even see some remnants of this reddish brownish substance floating inside of your beaker. Let's take a second to actually think through what happened during this process. So when we poured our sodium chloride and copper sulfate solution onto our aluminum foil, what you noticed was a chemical reaction. But what is actually happening during the chemical reaction is that the atoms are forming new bonds and old bonds are being broken down. And this is all done through the movement of electrons. Now, what happened to our aluminum foil? Did it disappear? No, not exactly. It hasn't disappeared. What has happened is the law of conservation of matter states that matter cannot be increased or decreased. It can only change form. So what's happened is our aluminum foil has lost electrons through the process of oxidation, where our sodium chloride solution has gained electrons through the process of reduction. Essentially, part of the aluminum foil has now become part of our solution. Here's an activity that you can try on your own to see another chemical change. For this experiment, you will need 200 milliliters of warm water in your beaker. You will need 2 plastic cups, your steel wool, which I've already divided into 2 pieces. You will need your blue scooper and your stir, your zinc disc, and your sodium chloride from your kit. Now the first step is to take a scoop of the sodium chloride and pour it into the warm water and stir. Make sure that you get the sodium chloride dissolved into the warm water. Next, divide the solution evenly between the 2 cups. Now take your zinc disc and you're going to drop your zinc disc into one of the cups. Last step, take your 2 pieces of steel wool and drop 1 piece in each cup. Now, your cups need to be placed in an area where they won't be disturbed overnight, and the next morning, observe what happens. Now that we've learned a little bit about chemical reactions, let's explore electricity and how it relates to chemical reactions. I have with me my copper strip, the zinc strip, Now that we've learned a little bit about chemical reactions, let's explore how chemical reactions and electricity are related. You need from your kit your copper strip, your zinc strip. I have the magnesium strip and the carbon strip, and as you can see, I've already gone ahead and attached them to the beaker with the blue clips that are located in your kit. You need your voltmeter, which is going to measure the voltage difference between our carbon and our magnesium. You need a cup of warm water, your blue scooper, your sodium chloride, and your stirrer. Now let's begin. After you have attached your magnesium strip and your carbon strip to the sides of the beaker, you want to then attach the voltmeter using the alligator clips. Connect the metal piece of the alligator clip directly to the magnesium using the black alligator clip, and then you're going to use the red alligator clip and do the same thing. Look at your voltmeter and make sure you have a reading of below 0. If not, you may need to switch your alligator clips. Now, we're going to start by pouring some water into our beaker. And as you're pouring the water, I want you to notice the change in your voltmeter. My reading is now at about 0.5. So that's an indicator that there are some electrons that are moving around. Next, let's see if we can increase the voltage difference between our carbon and our magnesium by adding some sodium chloride. I'm going to add a scoop of sodium chloride. Use my stirrer to stir it very carefully. I want to make sure that the sodium chloride is somewhat dissolved in the water. And now I'm going to check my voltmeter. My reading has increased. It is now reading at about 1.4. 1.4. That is the voltage difference between the magnesium and the carbon. If you want to keep experimenting to see how you can increase or decrease the voltage, all you have to do is add more water or add more salt and see what happens. Here's where you get to try an experiment on your own. I have gone ahead and attached each of the strips, the carbon, the magnesium, the zinc, and the copper to our beaker. I've also gone ahead and attached a piece of aluminum foil. Now, what you're able to do is you can take your alligator clip, your black alligator clip, and connect it to one of the strips. Take your second red alligator clip and connect it to another strip. Make sure that your strips are not touching each other. Now the voltmeter is going to measure the voltage between the two metals that you've connected your alligator clips to, and it will tell you if there is a chemical reaction occurring or if electrons are moving between these two metals. So as you can see, I have my zinc and my copper connected, and the voltage meter now reads about 0.5. When I disconnect the zinc and I connect it to, let's say, the magnesium, so now I have the magnesium and the copper connected, the voltmeter reads at about 1.2. So there's definitely electrons that are being passed around between these two different metals. In your kit, you have a lab book where you can test out these different metals to see what is the highest voltage that you're able to generate, and you can record your results in your lab book. Have fun testing. What is our voltmeter telling us? Well, our voltmeter is telling us that there is definitely a chemical reaction taking place between the sodium chloride and the water. There were no bubbles, there was no heat being released, there was no color change. So how were we able to determine that there was a chemical reaction? Well, that's where electricity comes into play. Electricity gives us the evidence to know that a chemical reaction is taking place. Remember, I said that electricity can be harnessed when electrons are moving. So because there is a reaction that we cannot see, we're able to measure this unseen reaction using our voltmeter, which tells us, yes, electrons are moving, so therefore there has to be some breaking down of bonds and some recreating of bonds between atoms as well. Thank you for joining me today for Engaging Saturdays with EM Educational Services. I hope that you enjoyed learning about electrochemistry. You have a few more activities that you're able to complete in your KiwiCo kit, and feel free to leave us a comment letting us know how the experiments go. Thank you, and see you next Saturday.